Okay, so applied optimization, you're working, again, practicing algebra, getting the review questions, practicing derivatives. I chose number 2 to show you. It's right out of the exercises. And I wanted to show you example 2, minimizing travel time. I'll debate that one in my head for a minute.
If we have time, can you explain the L-shaped one? Yeah.
Example 1.
Huh?
Example 1. Or number 4, 5, it's 5.
Like bend this tube. Yeah, and if no idea. Get the minimum distance between the ground.
Oh yeah.
Between the two ends.
Sure. Okay.
It has something to do with hypotenuse, I think. Yeah.
Yeah, that's a Pythagorean theorem problem.
I know, but what are the other? Yeah, what's the other equation?
Well, it's 4 meters. Bent into an L shape, so you know your constraint is the length of it. So you have a length x and a length y that equals 4. So x plus y equals 4. And then your other equations, x squared plus y squared equals z squared. Yeah, and that should do it. Okay, number 2. A wire of length 12 meters is divided into 2 pieces, and each piece is bent into a square. Okay, so we have 12 meters of wire. And we cut it and make square 1 and square 2. Okay, so cut wire and make it into 2 squares. All right, so like I said, half of this is deciphering what you have in front of you at the first. Okay, how should this be done in order to minimize the sum of the areas of the 2 squares? Minimize sum. There's no E on that. Not supposed to be. Come back. Of the areas, squares. Okay, so there's no standard surface area formula here, no standard perimeter formula. This is where you start to have to get some stuff out of your melons. You just smash it on the ground and it explodes, right? That's where we start. Right. So what's the first equation I can use? Yep. There's your constraint equation. Remember that word yesterday. Now, based on x, what is this? What are the side lengths here? X over 4. 4 sides to a square, they're all the same. So it's x divided by 4. And the other one is y over 4. Okay. So you're building these thinking in terms of geometry, which most of you didn't have a formal geometry course, right? What is the sum of the areas of the squares? X over 4 squared. That's y over 4 squared. Okay. So you're taking that English problem and making it a math problem. It's all words, now it's math.
Why is it squared and not 4?
Because area, side times side. Right, yeah. Okay, thanks for that. I don't, you're fine. School's like 3 days in for the semester and everybody's like stressed out already.
Pretty much,
Like just the thought of school stresses me out. Okay. We have 3 variables. We can only have 2, right? So we need to use that to plug in.
Do the constraint?
Yeah. So which one? Now let's go with y equals 12 minus x, right? And plug it in. Substitute. I guess that would be the formal math word. And you can simplify that. I suggest it. Okay. X squared over 16. And, yep. Oh, you know how to do that.
Wait, are you just distributing the, did you just foil the top?
I foil the top.
But just the top.
And square, oh, God, that should be 16. Is there a reason I'm not an engineer? Because I do stuff like that all the time. So I figured I'd just teach other people how to do it all the time. You know, yeah, it's good. All right, so simplify. They're 2x squared over 16. So that's x squared over 8. And then we have minus 24x over 16. That simplifies to 2 over 2. 12 times 12. 144 over 16 is 8? 9. Well, 9. That number doesn't matter anyways.
All he did was
Okay, x squared over 16 and x squared over 16. It means there are 2 x squareds over 16, which is x squared over 8. And then 24x over 16 is 3 over 2x. 144 over 16 is 9. Yeah. Yep. Yep. Good. All right, derivative. Two x over 8. It's just a number. This is just a number. It's like saying you can rewrite that as 1/8 x squared. So just the power rule. So bring the 2 down, subtract 1. So we get x over 4, right? Minus 3 over 2. If it's not a function on the bottom like 8x or x squared or a root or anything, it's just a number, it's just a fraction. So don't make it harder than it needs to be. Bring the 2 down. 2 over 8 is? 2/8, 1/4. Okay. All right, now we're on the same track. Set it equal to 0. I'm going to be a rebel. What does x equal? 6? Yes. Or backward 6. I said equal to backward 6. Never mind. Yes.
You just confused me so much. I was like, is that a thing?
Stop. Okay. Sometimes I can pull that stuff off with you guys. Like, apparently you're a little sensitive right now on applied optimization, so I will stop. Yeah, you bet. I know you do. I can see it. All right, so x is 6. What is y? How about that? All right, so remember, you get your formulas, find one variable, plug it in, derivative, set equals 0. Yeah. X is 6. 6 plus 6 is 12. Yeah. And you could use this one too if you want. 12 minus 6. Same thing. Okay. So that one's a little more involved than what I showed you yesterday, but it's the same idea. Get your formulas, plug one in, derivative, minimum, maximum. Okay, did I assign any that have time in them? Debate. Okay. Yeah. I did one yesterday. No, we didn't. We had 2 variables. Okay. So you're thinking 16. Nope, 16 is okay. Don't worry about it. Okay. What is the base shape? The cube is this, it's square, so you only have 2 variables still because they're the same size. Yeah.
That's why I stopped. I was like, I don't know what I'm doing. I'm going to time. I'm just going to start. Number 5, I tried like 1, 2, 3. Oh, I really wish there were more. Why are you laughing?
Hey. Sign that one. Okay, I'm gonna cross out 23 and 47. Yeah. 23 and 47. Did I assign anything else above 23? Oh, okay. Is it going to help you if I show you another one? Okay.
Like I got the stairs down. Yeah, like
Like the 2?
the L-shaped one, you have to like.
Number 5, you want me to do your homework for you? I just did one just like it. Right? I mean, so if you're looking at number 5, you have a length of wire bent into the shape of an L. Okay. Minimize the distance between the two endpoints. Okay. So this is number 5, x plus y equals 4, right? And then x squared plus y squared equals z squared. Pythagorean theorem is the function or the equation you need for minimizing. Yeah. What are we minimizing? Which variable? Z. So aside from here, you need to get z equals. And this is going to end up a chain rule derivative. Okay. Like this? No. Because then it's implicit differentiation, and that's not our friend. You don't need it. Okay. So you're going to solve for y or x, right? Plug it in. Take the derivative. Set it equal to 0, and it should come out. So, okay. So do you have enough guidance to, you have the idea of how to complete this? Okay. So let's talk derivatives of square roots then. Okay. Let's say this is f of x. How do I take the derivative of a square root? Okay. Good first step. Now, this should look very familiar from the warm-up. Yeah. What's the outside function? This is your first stop, outside. Okay, so use the power rule. And then copy the inside. Right? Now, that's the inside, so take the derivative. There you go.
You think it'll be that easy up there in our problem?
Yeah, it will. Yep.
When you do that, can you combine the 2x and the 1/2, or can you not do that?
Yes. Now rewrite this. Always, these are, this, I really have trouble working with this. So I rewrite it. So I have 2x on the top, and on the bottom I have 2 square root x squared plus 2. Right, this is a negative 1/2. Remember, negative exponents drop it underneath. That's 1/2, so it's still a square root. And then the 2 here, 1/2, and the 2 here. And these can actually cancel out. X plus 2. Okay.
Like the last part, like the bottom form, I just keep skipping because I don't know what to do.
Like here.
Yeah,
Okay, yeah. This exponent rule, the negative exponent rule, is going to be really big for you guys. Knowing that the negative exponent means it goes under the fraction. So get rid of this mess and simplify it. It's a lot easier to see.
Yeah, it's because it's 1/2.
Yeah, the 1/2, it's the 2 on the bottom. Okay.
No, I had to think about it.
All right, so take this and try that problem. If you need help, shout. Yes, we can start thinking of 80s songs. Yes, I know. These are the things I could do without, huh? Good? Yeah, how about that? Yeah, I beat you to it. How about that? Let me know how it works out for you when you don't need calculus, which is fine.